Well, I'm gonna go ahead and get started. It turns out most of the people in the room are on science. Cisco, for those of you who didn't attend, Cisco went all out on this. In the morning was great, lunch was great, and the afternoon break is, it's also as great. Everyone's still out there eating. It's such a great. But anyway, hi, I'm Duncan, and I'm going to be talking about the Open Cybersecurity Alliance. Everything in this talk is TLC clear, CC BY, so feel free to use it however you want to. I sent a copy of it out on the CSAP mailing list, so people who want to cheat ahead and get ahead of me in view graphs can do that. Although it won't have the builds that I'll have as I'm talking about it. Plus, a lot of it is just pictures, so it won't make any sense if I don't say anything anyway. So I'm going to talk about what the OCA is. I'm going to talk about why we need an OCA and why you guys should all participate in it, because what's its relevance to the VEX community. I'll be talking about how OCA can help VEX, and I'll be talking about how you all can help the OCA. A little bit about me, for those of you who haven't heard me babble a lot, and all the various meetings that went on forever on this stuff. Back in 1990, before probably some of the people in this room were born, I helped prepare the battlefield for the first Gulf War. I happened to have the right clearances, be in the right place. Went back to AT&T and said, hey, we live in a glass house here. We got to worry about this thing that actually at that time the word cybersecurity hadn't been created yet, but we need to worry about it anyway. So I've been involved with their efforts until I retired about 10 years ago. And now I'm just an old retired guy who likes to talk in conferences and participate in pro bono activities and standards of cybersecurity. My tagline's S-Fractal, and my handle is S-Fractal. My tagline's up there, think evilly, act ethically. So I also like to play with Raspberry Pis. Really hard to see the people in the room, but on the back here is a Raspberry Pi that looks like what's up on the screen. And you can't see it because it's covered with an LED array that I'm going to talk about a little bit more later, associated with some of the OCA activities. It'll look like that, but again, that'll be later in the talk. So I'm going to apologize in advance. I'm going to throw out a lot of acronyms. Hopefully I'll define all of them at least once. None of them are going to get the time that they deserve. So if anything up there or anything I say is of interest to you, I'm happy to talk with people afterwards. Those people know I love to talk, so that's not an issue. And I do have stickers to give out, both for OCA and something called the Cyber Automation Village. And speakers get first dibs on them, and then else in the room physically can do it. Again, the food was great. We have stickers. Next time we do one of these, all you people listening on the web, you should be here. So, what is the OCA? OCA is about making cybersecurity work together without needing custom integrations and without having vendor lock-ins. So OCA, or Open Cybersecurity Alliance, is a OASIS open project, which is slightly different than CSAP, which is an OASIS TC. I'll go into a little bit on OASIS, because we haven't said, I think, too much about it today. So just so people are aware, OASIS provides support for both open standards and open source development. It's the home of an awful lot of standards. Some of them up there you probably recognize. Some of them you might not recognize, but are really important. Like when you see those Amber Alerts when you're driving on the highway, that's actually an OASIS created with an OASIS standard. It is an ANSI accredited standards development organization. CSAP is, for those of you who aren't intimately involved in it, you may not know, but it's in the process of going to become a de jure standard in ISO at the moment. And OASIS is a sponsor of today. So back to this OASIS open project called the Open Cybersecurity Alliance. Here's what it's not. A bunch of names up on the board there. Those are the sponsors of this thing called the Open Cybersecurity Alliance. If you get to be a sponsor, you pay money to get to be a sponsor. You get to be on the board, which leads things, but it is an open project. Absolutely everybody can contribute. There's no constraints. You don't have to pay anything to be a part of it. So I would encourage you all, if you're here, if you're listening to this in the first place, you probably care about some of the work going on here. At least I hope you will by the end of today. So we overload the word project. So OCA is an OASIS open project. And there are projects within the Open Cybersecurity Alliance. So we call them sub-projects just to not get too confused. But they're listed up here. But the two of most importance to the VEX community are the two on the right. One's on cybersecurity automation, and one's on this thing called PACE, which I'll explain in a little while. But it turns out in the process of explaining both of them, I'll actually explain most of the stuff on the left, as well as a whole bunch of other projects. So why are we do an OCA? Why do we need to do it? Well, there are no silver bullets in cybersecurity, but neither are we fighting werewolves. It's more like we're fighting off a herd of zombies. So what we need are shotguns, okay? Shotguns have little pellets, and they have gunpowder to power them, and they're all in a case. So our pellets are all these acronyms and stuff that I'm gonna be talking about, one of which is VEX. VEX is just one pellet in ours. It's not a silver bullet in its own right either. Okay, it needs to go with all this other stuff. That's what OCA is about, getting all this other stuff to work together. Now, automation is the thing that's gonna power this whole thing. And the shell that holds all together is sharing and cooperation. So, mentioned automation. We talked about it in some of the earlier talks today. And the reason we need automation is because attacks are coming in at the speed of light, and we're responding at the speed of lawyers. And that's why we have the mishaps that we have today. Now, I said I'm talking about why we have the OCA. That's still not why we have the OCA. Why we have the OCA comes from Jerry Maguire. Show me the money. It came up in a couple of talks earlier today. Somebody mentioned, I think it was Chris Blass mentioned, and I'm really surprised he has not read this book before. I do highly recommend this book. It is a textbook. So, you know, take it. It's not going to be a novel to keep you up late at night doing, but it's got some really good concepts in it. And it's how to basically talk to your CFO, how to talk to your business about cybersecurity. I firmly believe if everybody read this book, we wouldn't have half the problems we have today, because it would clearly justify doing CSAP and all this other stuff. And the reason is because they have stuff in there like something called, something called a loss exceedance curve. This is the type of thing your CFO does. It's how financial quants quantify risk, okay? If you read this chart, you look at things like there's a pretty high probability that you're gonna lose at least $1,000 in the next year. The most likely view is you're gonna lose, I have in there, 5 million, okay? And there's a chance, it's a 3% chance, you're gonna lose 400 million. And there's ways to come up with those numbers. We'll talk about a little how they relate to some VEX stuff in a while. But again, it's the stuff that's in this book. Highly recommend it. And everyone says, I can't really figure it out. You need to be too accurate. You don't need to be too accurate. You just need to be accurate enough to do comparisons. Like, do I have a supply chain security system, and if I, or ecosystem, and if I don't, should I have one? And the chart I showed before might be that, hey, we put VEX in and we do it. And the orange is the baseline that we had beforehand. And we say, hey, look, it's going to cost money to do this. That's a fixed cost. If we put this, you know, we were talking earlier, it's going to cost us something to put VEX in. Let's just say that's $100,000. Well, that's spent money. And at least on this chart, this particular chart, there's a 5% chance you wasted that money. You didn't need to. Okay. But again, this is a hypothetical example, but in this particular case, it saved $4 million. We're going to spend $100K to save $4 million, and that's like a no-brainer. And it might even be, even if that was a tie, you might do it, because in this particular case, it lowers the chance of an existential problem. Like the $400 million loss was reduced from a 10% chance, which might be above your risk tolerance, to a 3% chance, which might be within the risk tolerance. So where do you get this type of data that you'll need to prove in all the stuff we're doing on cybersecurity automation? So here's a slide from many years ago. Came from the Johns Hopkins University Applied Physics Lab. It was pretty academic, the underlying slide, so I made that sort of overlay on top of it, which is, again, it's still not the bottom line. The bottom line is they kicked hackers out. Hackers that used to be in for weeks, they kicked out in hours. So it was a 2 order of magnitude improvement in reducing the amount of damage and stuff. So that's the type of money that you plug into those other expressions. Another one was, again, this is from that same year ago conference that the government sponsored. This is from a managed security supplier in the UK, and they were looking at just the efficiency of their SOC team and just standardizing on the language they used in their playbooks. They saw a 25% improvement. So nothing against Cisco, but you know, that they didn't have to have one developer who knew how to program a Cisco firewall, and a different developer who knew how to program a VMware firewall, and a different programmer who knew how to program a Palo Alto firewall. They used a common language for all of them, and it saved them a lot of money. This is from a SOAR provider, similar time frame, actually same conference. They saw a factor of 50 improvement in their processing of phishing emails by putting in automation. For a particular customer, it saved $1 million a year and justified doing all this stuff. So back to the OCA. The OCA's got these projects. One of them's on automation. That's the one I'm going to talk about a little bit. It's called the Cybersecurity Line Cybersecurity Automation Subproject. So OCA CASP. We love our acronyms. So it's a group of people working on automation. It's an open project. Anybody can work on it. It's going to get into the alphabet soup that we talked about earlier. But besides having a bunch of meetings and figure out how to get all the stuff work together, we run events. And we recently ran an event called the Cybersecurity Automation Village. And that's its fancy logo, and that's one of the stickers I have if people want it. It was out at the University of Southern California. It was the day before SBOM-orama, for those of you who went to SBOM-orama. And we call them a village because it's a combination of a workshop like this, a bunch of people talking. It's also a plug fest where we actually get real stuff to actually cook to each other and talk to each other, as well as the hackathon, because working we talk to each other, so you need to program stuff. And plus it goes nice with the It Takes a Village, because this really is one of those things where a lot of things work together. So there were 17 projects involved. Some of them more involved than others, but all of them were involved. There were 6 other OCA subprojects. So CASP is one project of it. There were 6 other ones. They were all part of it. It's an OCA event. There's also one other OASIS open project, a project called NEAM. And there were 8 OASIS technical committees, so again, which this was one of them. And then we sort of have a catch-all that we said, and we also doing SBOM stuff and VEX stuff, which, as you all know, SBOM is really a front for 3 or more, depending on who you talk to. And VEX is, again, a front for 3 or more, depending on who you talk to. So partly it was for simplifying the slides, so we didn't include absolutely everything on there, because it would have taken up too much mind share. So one of the purposes of the project is to show how these things work together and benefit the end enterprise. And this particular chart is showing, for just one of the particular projects, how it interacted with the others. But obviously the one you care about is the VEX project or CSAP project. Now, in our particular case, we made them 2 different projects because we're sort of hopeful we get to more than one aspect of, not just the VEX profile, but the other profiles of CSAP. And we want to at least allow for the fact that we could have one of the other 2 VEX formats in there. It turns out for this particular event, we just had we did not have any other VEX formats, and we only used the VEX format of CSAP. But again, in the future, we'd like to do more. So there are multiple aspects to the plug fest of this. In the ideal case, we'd have working code from different organizations talking to each other over standard interfaces. Somebody in one of the earlier talks asked about the what part needs to be proprietary and what part needs to be standard. And that's what we're really trying to get at. We're really trying to get at where do we need the open interfaces so that stuff will all play together. Right? We want to keep the proprietary stuff where it belongs, but allow the stuff to work together. So the 9 organizations across the middle there all brought what we call sweat equities. They brought working stuff to talk to the other people's stuff. And we did it all in the context of a use case. We sort of ahead of time said, hey, when we go off and do our own use cases at each one of these projects, they're all very central to that project, but they sort of don't really mean anything to the end enterprises. They're all, the STIX stuff is very STIX oriented, the CSAP stuff is very CSAP oriented. We want it to be, what do the big what the Bank of America care about any of this? We want to say, what's it mean to them? So we picked a ransomware use case, and I'll go into that in a little bit more detail. So the 9 organizations that I just discussed with actual working code did machine interfaces on 11 of the projects on my fancy circle there. But we also had humans involved. So there were a couple tools. There were 2 sets of, it's like today an open source tool got released, which was great. For this village, 2 open source tools got related. And again, in automation, you don't want humans in the loop, okay? But you do want humans ahead of the time determining the policies, setting the stuff up, and both the tools I'll talk about help with that. And that's just where they're related. And we have to admit, sometimes hand waving is involved. So for example, we have had both past villages and at this villages, we have had what I'll call PACE vendors. I won't explain what PACE is yet, but basically the manifests and the side beats and the archivists, and I forget what other SBOM vendors are in the room at the moment. Those are what I'll classify as something called a PACE vendor. And they've been there, and they may not have had the exact standard interfaces that we talked about. And we'd say, but that's okay. Wave our hands. If we had a shim that converted your proprietary interface to one of these other ones, then it would work. And so they were allowed to participate that way. The other way that there was a lot of hand waving is we always sort of do, hey, here's what we can do today, but here's where we're going to be by next year. And so there was a lot of hand waving on what's coming in the future. So we made up this hypothetical ransomware use case, and we looked at it from various perspectives. We didn't take ourselves too seriously. We introduced some humor. We actually literally got feedback at the village that we maybe should have been a little more serious with some of the stuff than we did. But most people like the fact that we had the humor in there. And there's a GitHub page, you can go read the details, a page long, or more than a page of the actual details. I'll cover the sort of high level, but you'll pick up a little bit of humor in some of it. So we started with a fictitious law firm, which we called Murphy's Law. Because their name was Murphy's Law, the attack occurred at the worst possible moment. But this is a sunny day example. And this particular firm implemented all this automation stuff that we're talking about in the OCA. And because they did that, they quickly kicked out the attackers using some of the tools we'll talk about in a minute. They then shared that information with their peers in the industry through their ISAC, using some of the other tools I'll talk about in a minute. And they even shared new vulnerabilities that they discovered that the hackers took advantage of using VEX, which I'll also talk about in a little bit of a while. So before I get into the details of some of that, let me get through the rest of the use cases. So the very next day, so we did it on a day basis. Day one was the 0 day that hit Murphy's Law. Day two was, it was still a 0 day. No one had put the fixes in yet, but another company got hit, but they were able to react really quickly because they got this shared information from the day before. So they were able to respond very quickly. So used a similar set of tools to the day before, but not in the exact same order. And again, the actual, went through a lot of details of this. And those VEX doesn't happen to appear on this one. It appeared on the first one because they got created. Didn't appear on this one, but it does appear again on day three. Day three is, hey, after a while, it's no longer a 0 day. You've actually figured out what's going on. And so the exploit's now a known quantity, okay? And at the advice of their ISAC, the third company, which was Triumphant Cleanup, I forgot to mention the second company, which was On Deck Holdings, they went ahead and they never even got attacked. Okay, and we can get into some of the details in a minute or two, but that's because they analyzed their SBOMs, they used their PACE system, which I'll explain what that is in a minute, and they used the VEX information they had. And then on day four, the US government got involved, and the Never Say Anything and No Such Agency in the US Department of Useless Factoids adds to their comply to connect use case. Many government agencies in the US have, it's actually a US law that they're supposed to be comply to connect. You're not supposed to connect stuff to your network unless you know its security posture. Well, in this particular case, this agency put out guidance that said, hey, because there's new information we just found out about the Whitchy ransomware, you should be looking for this new thing before you do your comply to connect. And that was a use case that we went through. Again, VEX is very important for that particular use case. And then on day five, turns out on days 1 through 4, all those companies involved had been keeping law enforcement involved. And so on day 5, the FBI, the Royal Canadian Mounted Police, Europol, and Interpol take down criminals across 6 countries. And then it can be neither confirmed nor denied whether rogue nation states were involved in this use case, just that it can be neither confirmed nor denied whether NATO allies and hunt forward operations hacked or bricked adversary consumers on day 6. And that's out of scope for our particular village, other than to note that it's actually a valid scenario for the tools that we're talking about. And NEAN, one of the tools on here, even has a MilOps domain in it for doing what I just said. So now we'll go back to the days and say, hey, what's this alphabet soup, and how's it accomplish this stuff you're talking about, and what did you actually show and prove? So remember Murphy Law, they got attacked, but they kicked the hackers out right away. So the first step that you have to do when you're hacked is something called threat hunting. Threat hunting is finding the attacker in your system. Now, Kestrel is an OCA project, so an OCA sub-project, so part of the Open Cybersecurity Alliance, specifically for threat hunting. It's a threat hunting language which provides an abstraction for threat hunters so they can focus on what to hunt, not how to hunt. It's an open source project. It even has a cloud sandbox, so anybody who's particularly interested in using it, you can go to the website and get it, and you can start playing with it yourself using one of their cloud implementations. So again, once you found the attackers, what do you do about it? Well, you use playbooks to orchestrate your response. Cacao is an OASIS standard for defining the schema and technology taxonomy for security playbooks. So how these playbooks can be created, how you can document them, and how you can share them. So if you visualize the Cacao playbook, it looks an awful lot like VPNN. It turns out CISO released 81 VPNN playbooks on how to deal with common attacks. Fortunately, none of them had S-bombs or VEXs in them, but we can hopefully work on that some. And if you look at this, or I should mention, what came out at, one of the things that came out at the Village is one of the participants brought as their sweat equity an open source tool that converts VPNN to Cacao playbooks. So as of the Village, all 81 of those CISA playbooks are now actual Cacao playbooks that anybody can use. And there are actually vendors that take Cacao and SOAR vendors.
Is this one right or left?
Was that to me?
I'm sorry?
Thank you. There might be an open mic.
I think it's Dennis.
Oh, okay, then I got it right.
You got it right.
Mine is right.
I guess I got it wrong. Did you mute your mic?
I just muted.
Okay.
You got it right.
So anyway, the things that go on in these boxes are command and control actions to your cybersecurity stuff. So OpenC2 is an OASIS specification. It's a standardized language on basically how to do cybersecurity command and control of your technologies. So this particular playbook is an OASIS, I'm sorry, a Cacao playbook being shown here. And it's actually not from this year's Village, but from last year's Village, okay? And it's about how to make use of what we used at the time called the flags in CSAP, but we now call the status justifications in CSAP. And it was an actual real life that we really used the flags to make different decisions. I'm gonna talk about a little bit in a minute when we get to comply to connect on our days. But some of the results are you actually send different OpenC2 commands dependent on what you saw in those justifications. In other words, you might say a component not present, yeah, just go ahead and connect them. I trust my vendor when he says that. But if it's one of these, not executable ones, it might be, well, maybe we'll up the monitoring a little bit. We'll send commands so we at least watch them a little closer than we watch most people. Or it might even be, we'll let them in, but we're going to turn Kestrel on and we're going to use it almost like a honeypot, but we're at least going to watch it. So back to day one in Murphy's Law. So we've sort of covered how they kicked them out quickly. Okay. So now let's talk about how they share the information. Cacao playbooks can be shared via something called STIX course of action. So STIX is an OASIS standard. Hopefully most of you have heard of it already. It's for threat sharing. And in this particular use case, Murphy's Law was connected to their ISAC through a taxi server, which is what the US government at least uses, and most ISACs use for the transmission of STIX information. And taxi is another OASIS standard. For our Village, we actually stood up a taxi server so different organizations could talk to each other with their STIX information over that. STIX shifter, which is in there, is a shim basic, I'll oversimplify it as a shim, but it's for taking data that is not STIX information and turning it into STIX information. So particularly if you have proprietary data sources, you have vendor specific information, they don't happen to have a STIX interface, you can use STIX Fisher to turn that into the threat intelligence that belongs in STIX. The threat actor context down there is another OASIS technical committee, and that's for extending STIX to describe the actions of threat actors, of the bad guys, follow campaigns, things like that. Indicators of behavior, or IOB, is another Open Cybersecurity Alliance project, and it's on extending STIX on how the different behaviors and the different patterns are used there. and how you can share that information. In this particular use case, all of those were used, and in the actual day when we're doing this, people actually literally exchanged real life information. Some of it, most of it, fake, but some of it actually anonymized real data from some of the customers. So it was real working code. It was a big success from that. And then another tool that was as part of the sharing information, shared, released, and shared for the first time at the village, was a tool for converting STIX objects into Neo4j, which is very good for visualizing. And if you've ever actually seen a real for a real campaign with the real STIX information, they're really complicated. There's a really lot of data in there. It's hard for a human to, well, first of all, you're reading JSON, it's hard enough to do in the first place. But it's, you know, pages and pages and pages. But if you plug it in Neo4j, you can make these pretty pictures, and even the pretty pictures are way more complicated. This is a real picture of a real attack. But even the original of it is really complicated. But what the human could then do using tools like this is then use Neo4j and say, oh, this stuff all goes together, this stuff all goes together, hit the button, and then you get this kind of picture, which is much more easier to understand what's actually going on. So still on day one, we'll get through that quickly. So we've now kicked out the attackers, we've now shared the information with our ISAC, but there was a 0-day involved here. There was a vulnerability that had previously been announced. So in this particular use case, the law firm used VEX as part of its responsible disclosure to its suppliers, because its suppliers was more maybe insightful than we've been talking about earlier, and required that they got their disclosures using VEX, because that's what it's for. It's for passing information like that. So in other words, it's not just for suppliers to tell their customers, it's also for customers to tell their suppliers. I know that's going to be a much less used use case than the not affected use case. So if I look through all the VEXs in the world 10 years from now, there's going to be way more not affected. But this is still a really important use case because it allows the automation, it allows both sides. Again, humans are still going to have to be involved in making the decision. Once you've made the decision, the passing of the information can be done on machine to machine, which allows better tooling on both sides. So day 3, I introduced this thing called PACE. PACE is Posture Attribute Collection and Evaluation. It's another open cybersecurity sub-project. It's how you take security information, or how you take security posture information, and you collect it, you evaluate it, and you store it. And in fact, you look at the 3 parts to a VEX, the 3 parts to a PACE system, those are the 3 parts. And if you have systems that do any one of those 3, you're either collecting upstream information about your SBOMs, VEXs, CVEs, etc., or you're combining the information. You're saying, hey, here's the SBOMs. I'm analyzing it, looking against the NVD, and saying, hey, these particular ones are affected. That means you're doing a PACE evaluation function. And if you're storing this, you can get at it later, particularly so that decisions can be made, like the Cal playbook I showed earlier, which I'll show another one in a second. That's the type of data that you use. So a little more detail on day 3 on what we actually did, when we were doing the scenario, was that this crime event cleanup company got the STIX information from they got the STIX bundle from their ISAC. They saw in it that there were these vulnerabilities, this particular new CVE that just got created, as a result of all this. They put it into their PACE system. The PACE system determined that, hey, you have 70 devices affected by the CVE, but because they had VEXs, they determined that, hey, for 40 of those devices, we have the VEXs, they're not affected, don't worry about it, focus on the 30 that you do need to worry about, and then using other information in the PACE system, they prioritized them and did the more critical ones first and did what they needed. But they did all that, again, because we're doing all sunny-day scenarios here, they did all that before the attackers got to them, and they never got hacked in the first place. Again, one of the business justifications on why you do these things. Now, on day 4, I mentioned this is the never say anything and no such agency. The U.S. government doing the comply to connect use case. This is the same picture I showed before. It's the oversimplified comply to connect. It's got some stuff sort of at the top that we just jump off, and you go to sort of different playbooks. But if you do have an SBOM and you do have a VEX, then this is basically where you look at, hey, let's look at that status justification. And if it's component not present, my particular policy of this particular company is, yeah, just go ahead and connect it. But depending on the state of some of those other choices, you might say, oh, well, I'm still gonna connect it, but I'm gonna turn on the IDS, turn up the knobs on the IDS and the firewall a little bit and watch this one a little bit closer. Or maybe even, because it's in a critical component of my infrastructure, so not just based on this flag, but based on other information as well. I might say, no, I'm gonna leave Kestrel running, just in case the hacker ever gets in there. I wanna find him right away, And again, this is a visualization of a Kakao playbook. The commands in those square boxes are all OpenC2 commands that we actually ran in the use case a year ago, or the village a year ago. And the decision boxes, the triangles, the data to decide go right or go left is coming from your PACE system. That's the purpose of PACE, is to help you with that security posture. So let me finish the village discussion. Getting back to my Raspberry Pi line here. Oops, I actually forgot to start it when we were getting going. It's supposed to be changing colors. So it's going to be through a whole bunch of colors by now. So the Raspberry Pi was part of my sweat equity that I actually brought to the village. It actually has most of the stuff that we did was on servers in the cloud. It was a hybrid event. There were a bunch of people in the room. There were actually people from 4 continents present on a hybrid, which is a little bit less than last year. Last year we actually had 5 continents, but this one we did on a little bit quicker notice. So we weren't even sure we could pull it off, so we didn't tell that many people that ahead of it. So most of it again was done with servers and was, hey, you see lines of code and whatever scrying, a black screen with a bunch of white lines, flying by. But it always helped to have some blinky lights. So we did bring a Raspberry Pi. That Raspberry Pi has on it most of the stuff that we've talked about today. Yes, there's a little hand waving involved for a couple of the aspects. And today's hand waving is at the actual one, you could talk to it, different people in the room could talk to it through the real internet and stuff like that. And even that was, I did some hand waving because of networking. I didn't even attempt to set that up today. So this is literally just hooked to my computer and I'm telling it what to do. But I can tell it what to do with OpenC2 commands, and it does have some of the other features in there. And at the actual, in June in California, particularly for the digital twin of this up on a server, this is Blinky, we had a thing called Twinkly, which is basically digital twin of this, which has its own SBOM present on it, which you can query it and it'll give you the SBOM. The Twinkly had not only its SBOM, it had a VEX that went with it, because again, SBOMs are more static, and even though I don't think they're static, they're just more static than VEXs are. And the cloud was the easier place to keep the VEX for it. And again, it was just a simple one that said, hey, log4j does not affect the software on this because it has to be written in Elixir. It's on a NERVS operating system. There's literally no Java in the system. So even though I don't have a complete SBOM for it, I'm confident that it is not affected by log4j. So the interoperation portion of the village was a success because this is written in Elixir. We had people who had written Python implementations of some of this, and the two could talk to each other, so that's a good sign. They didn't talk to each other perfectly, so some of it was bugs in my code, bugs in their code. That's useful to discover. But some of it was also bugs in specs. One of the main reasons for doing it so we could discover that, hey, we didn't really specify that well enough, because I read it as red and you read it as blue, and we don't actually talk to each other anymore. So we better spec that better in our specifications. And it's the main reason we do these things, which is really good. That and to show the value of it all. So if you're interested, the whole thing was recorded. It's about 4 hours long. If you go to the GitHub for the PACE or for the CAST project, if you go to OCA, you'll find the automation project. If you go to automation project, you'll find it's got a GitHub. If you go to the GitHub, you'll find the plug fest. If you go to this particular plug fest, you'll find this page, and you can listen to the whole 4 hours. You can click on any particular part of it and jump to any part of the video if you want to. So we did throw the previous village together rather quickly because we didn't get a whole lot of notice on the SysBomb, SBOM, RAM. I decided, hey, that'd be a good thing to go to, and arrange with RIT and USC to help host us. And once we thought we could actually pull it off, we then told people about it. So we decided, hey, we should be better off next time. We should plan more ahead, and also done, we need more time to plan, and we need more time in the actual event. So the next event's planned to be a 2-day event. It's going to be in March of next year. A host is in the there is one of the previous hosts is agreeing to host again, but they're still going through approval process, and so I can't announce who they are yet. And once they figure it out themselves, they'll decide whether it's their New Jersey or the DC location with the exact dates that we'll figure out. And I would encourage you all to participate, particularly all of those of you that are in the SBOM management space or VEX management space, or we'll call it PACE evaluation space. And I'd recommend I'll call it the user community to get involved too, because one of the particular host that's hosting this is a very major purchaser of a lot of this stuff. And they're basically going to tell all their vendors, hey, show up, tell us how this stuff works together. So hopefully I answered these questions of, sort of what is the OCA? It's getting all this stuff to work together. Why is it relevant? Is, again, it's because financially it's the smart thing to do. How can OCA help the VEX community? It's one of the uses of VEX. It uses VEX in what it does. As part of just having a VEX doesn't help. It's that comply to connect use case and the money saved from the it's try and evade cleanup or whatever. That's the business justification of why people need these things. And then what you all can do is help by helping out with OCA, going to the village and stuff like that. So there's never enough time. Thank you for yours. I think I have plenty of time for questions if people have questions. The lights have been changing throughout. They're supposed to start that one earlier.
Not a question, but a
Are any
comment.
of you awake?
Yeah.
Not a question, but a comment. I put the link to the GitHub repository for OASIS that includes all the different repositories in the chat, and we'll make them available. It's okay to make available the
Yeah,
links.
yeah.
What's the deal with the Raspberry Pi?
What's that?
What's the deal with the Raspberry Pi? Why'd you bring it up?
Oh, because this was my sweat equity I brought to the village. It actually has coded on it the actual, like, these lights are changing colors. It's actually, I literally, one of the earlier talks today, I really wrote the code in Elixir to send the OpenC2 commands to this, because I don't have the networking set up. There's actually an OC2 test server out in the cloud that's what we really used in the village. But for today, I didn't want to worry about the networking. So I wrote some code to just basically send the commands to change the colors every 5 minutes. Also help me know whether, like, if it's still on, we're still on purple, so I know I'm a little ahead of schedule. Because I talk too fast, I apologize. But yeah, it's an actual implementation that was part of how the, the ATP stuff talked to the NSA stuff, talked to the IBM stuff. Like I said, we did most of it with what I call its digital twin. So this has blinky lights under control by OpenC2. It's got its SBOM, and you give an OpenC2 command to it, stuff like that. And it's got some fake stuff that you can pretend you're playing with its internal firewall and stuff like that. That's one of my hand wavers. But there's also a twink, and it talks over MQTT with the OpenC2 commands. There's a twinkly version of it, which is basically the same code but running in the cloud. Although weirdly enough, with a much longer SBOM, because this has real LEDs to control that. I had to make a little screen and make fake LEDs on it. To do that, I use JavaScript. Well, once you put JavaScript in your SBOM, you haven't updated every other day. But yeah. Anything else? And I can't see the chat, so you guys will have to tell me if anything comes up on the chat.
I don't see any hand raised now.
What was the next village that was scheduled?
So it's a 2-day event. It's going to be in March. Exact dates to be determined, dependent on host availability, which is dependent on whether they pick New Jersey or DC. So they are hosted one of the previous ones. They have a very nice facility in DC that we did one of the previous ones at, but the bulk of their people are in New Jersey, and they're still working on some of those. Plus the one in DC was being used a lot by other people. And anything else? It's late today, you all want to get home.
What was the name of the book?
Oh, the book, How to Measure Anything in Cybersecurity Risk. It's by Douglas Hubbard, who's an expert in risk, but not cybersecurity, and Richard Searson, who's an expert in cybersecurity. It's fairly old. I think it should be required reading by anybody who has anything to do with software, let alone to do with cybersecurity. referred to as the Green Book. It's a textbook in about 8 colleges around the country now, I believe. But it's got a lot of intuitively obvious stuff in it once you read it, but it's also got a lot in it on how to calibrate well, first of all, how there's a lot more data available on what cybersecurity is going to cost you and how you can make those probability curves. Everyone sort of can say, here's what it cost me last year, but what's the probability you're going to be the next Target or Home Depot? That's harder. It's actually not that hard. The people in the financial industry, insurance industry, disaster areas have been doing this kind of prediction for a long time. And this basically just takes, that's where Hubbard made his name, basically just takes his work and applies it to cybersecurity. And I'm surprised it's not a lot more common.
I just ordered that on Amazon. It was $45 plus tax. It came out to $50, and I plan to expense this, by the way.
I can guarantee you, if you figure out the loss exceedance curve if you read the book, you can do your 2 curves of loss exceedance, and it'll definitely have saved you $50. It'll definitely save your company $50 because you're smarter in how to tell your upper management and your board the stuff they care about. They don't care about CVEs. They don't care about SMOs. They don't care about CSAFs. Okay, they care about what's it mean to the company's actual line of business, and that's how to take VEXs and turn them into what it matters to the company's life.
Could someone post the name of that book in the chat, please?
Yeah, we did a couple of times. So Martin pasted a link directly to the book, and then it's how to measure anything in cybersecurity risk. David Prater also put it in the chat.
And my slides are already on the CSAF mailing list, and it's on one of the slides. And obviously, it will eventually be available to them.
Also, Jeff Boddington mentioned that there's a 2nd edition coming soon.
Correct. Been coming soon for a while, but anything else? Well, with that, we can, I don't know, turn it over to the next speaker or take another break. That's your call because we're ahead of schedule.